Hi, so this one's going to be 2.2 part 2 for precalc. Just a couple different things to kind of finish up here for 2.2. All of it's going to be on the graphing calculator. So if you do not have your own TI 83, 84, something that can graph, even if you have an Inspire, that's fine. Go ahead and go to desmos.com. Go ahead and download an app on your phone. Make sure it's a free one. We don't need to pay for it. Or just simply Google graphing calculator and you'll pop up tons of different options. So the reason we're doing this is we, in the last video, did all sorts of things on how to find zeros algebraically. So we factored and then we solved for x and we found all of these different zeros. But we can also do that process graphically. So specifically, you're going to get lots of these different kinds of questions on an SAT. If it's on the non-calculator portion, you'll know how to do it from the last video. But if it's on the calculator portion, this is going to teach you how to do that in a much, much, much faster way, which is what the calculator portion is needing, right? So the first one we're going to try is f of x equals negative x cubed plus 4x. So the first thing that we do is we go ahead and hit this y equals button, and we need to go in and type in our function. Okay, so go ahead and type that in. As soon as we're done, we press this graph button. So then up pops this graph for us. So what a zero truly means is, and we talked about this last time, it's an x-intercept, it's a factor, it's a zero, and it's a solution. Right? All of these four things are all equal to each other. So when we specifically talk about the graph of them and how you can visually see zeros, let me make sure I have. This is me trying to graph what's on my calculator right now, and I'm not doing the most hot job. But zeros happen when I cross the x-axis, right? X-intercepts are my zeros. So at this point, and at this point, I have a zero, okay? Let's think back to, we were told that you can have it at most n zeros, n being my highest degree. My highest degree or highest exponent in this function is 3. So I can have at most 3 zeros. So we come back to my graph and I say, this point is x equals negative 2. X equals 0 at this point, and here x equals positive 2. Those are 3 different zeros. I'm visually seeing them cross my x-axis, but that's not quite good enough for me because sometimes it's not going to be a clean slice through my x-axis. So I see them, and now I'm going to test it. The way that we test this is by doing second trace, just like how we did to find our minimums and maximums, but this time we go down to 0 and then press enter. So this little spider, what we need to do with him this time is take it to the left of where I see a 0. So I'm going to slide him all the way over here. Whoop, doesn't need to go up quite so high, and then I'm going to press enter. So now I have to go to my right bound. So I go down to the right or below where I see it crossing the x-axis, and I press enter again. Okay, so that second spider guy would have been right down here. Tells me to guess. We never guess. So I go ahead and press enter again. And you're popping up x equals negative 2 and y equals 0. We claimed that one of my zeros was negative 2, so I'm good. That is an actual 0. So I'm going to start listing these out, and x equals negative 2 is one of them. You're going to repeat this process for this, try to find a good spot, for inside here and that one as well. Okay, so now I'm going to say, all right, I'm going to go again. Second trace, I'm going to find another 0. Go down to 0, press enter. This time, I need my spider right here. So I moved him over to right there, and I'm going to press enter. Now I go right bound. I need my spider up above here. So I move it. I call it a spider just because most calculators, it looks like a spider. Press enter again. If you see that close enough, x equals 0. I said I thought my 0 was x equals 0. It is, in fact, a 0. We do this one last time for our third one. I go second trace one more time, down to 0. Press enter. My spider should be here and there. So I move it over. That's good enough for me. Press enter. Move it down a little bit more. Press enter. Enter one more time. X equals positive 2 is a 0. So that's my last 0. All 3 of my zeros worked. They were all in fact zeros. So I'm good, right? So sometimes like factoring this wouldn't have been that difficult, right? I could have done that maybe even faster than using my calculator for this, but it's a good way to check yourself too. And some people would argue like, no, for sure, this is much quicker than factoring it, whatever works best for you. Either way, that is that same process every single time. Just keep in mind, you have to do that 0 process in your calculator for each and every single 0 that you see. If I cross my x-axis once, I'd have 1 0. If I cross it 5 times, I'd have 5 zeros. Okay, whatever, however many times you cross. So there's one more thing that I want to talk about, and that is multiplicities. So what happens when we have a multiplicity is we basically have 2 zeros at the same point, okay? Or we can think of it as 2 zeros at the same x value, right? Because that same x coordinate or same point. So when this happens, and this is just an example, let's say I had a parabola or even a cubic function, and I went like this, and I touched, and I went back up. Okay, so here's a 0, and that's just 1, right across my x-axis. At this point, it's kind of a very hard process to think of, but we came and we hit it once, and now we hit it twice. So at this point, I did not go through the graph. I'm simply touching and going back up. So when this happens, I in fact have 2 zeros at this point. We're going to call this point 2. So x equals 2 and x equals 2. There's 2 zeros at this point. Okay, this would be a cubic function, which would mean that I have the possibility of having up to 3 zeros. So here's 1, here's 2, here's 3. Okay, so I'm going to show you an example of this on your calculator. I'm not going to make you actually factor these out by yourself because generally they're really, really high degree polynomials and difficult to factor. So I'm not going to make you factor them. This will only be something that you do graphically. The example is x to the 5th minus 3x cubed minus x cubed squared minus 4x minus 1. Okay, so same thing. We are going to go ahead and put this into our y equals. So I go back to y equals. I'm actually going to clear out. Where's my clear? I'm going to clear out this function and start over. So x to the 5th minus 3x to the 3rd minus x squared minus 4x minus 1. And graph it. Oh, I'm sorry, that's not the one that I wanted to do. So sorry, this was not the function I wanted to do. That shows a different kind. So sorry. Let's actually do, let's do y equals negative 2x to the fourth plus 2x squared. Let me check this one before I make all you guys do it though. Okay, perfect. So this one works. So we've done this one before. You can't quite see what's going on, so I'm gonna hit my zoom button and I'm gonna go zoom in, press enter, then you have to press enter one more time. So what we see happening here is I'm getting this kind of M shape where I hit and I come back up and I go back down. So right here at 0, I'm touching my graph twice, okay? Since I'm touching my x-axis and going back up, there's technically 2 zeros there. So let's check this. My highest degree was 4, so I can have at most 4 zeros. So when I look here, here's 1, here's 2, okay? But there are my second 2 zeros. So I technically have 4 zeros here. I don't care about these outside ones right now, but the way we would write this is x equals 0, and then this is 1, and this is 1. So it'd be x equals -1 and x equals +1 as all 4 of my zeros there. Okay, so just keep in mind, anytime you see that there is a point in which we touch a graph and then immediately go back up, that's going to be 2 zeros there, or a multiplicity. Okay. So the very last thing I want us to do is I want to go backwards, okay? This is the one thing that we'll do today that doesn't require a calculator. So I want us to start with zeros given to us. So this means I tell you that the zeros are -2, -2, and 3/4. So you can't see any of that. -2, -2, and 3/4. So what I want you to do is write the polynomial. With the given zeros. Okay, so if these are the zeros I'm given, what this means is this was x equals -2, x equals -2, and x equals +3/4, right? When we find zeros, it's all x equals, x equals, x equals. What we want to do is go backwards. So I want to get this set to 0, this set to 0, and this set to 0. I would do that in this case by adding 2. So I have x plus 2 equals 0. Same thing over here, add 2. X plus 2 equals 0. Over here, it's a little bit more difficult, not too much though. My first step, I need to multiply by 4. So I now have 4x equals 3, because those cancel out. Now I need to subtract 3. So 4x minus 3 equals 0. So what we get to do is multiply these out completely. Okay? So this is a factor, this is a factor, and this is a factor. So I'm going to set this factor up, x plus 2, this factor up, x plus 2, and this factor, or x minus 3. Okay, and I'll take you up here. Okay, I set those all up in a line. What I need to do now is basically FOIL all these. I need to distribute them out. So what this will look like is multiplying these two binomials together first. This one's just going to hang out for a little bit. I'm not doing anything with this one yet. I take x times x, which is x squared, x times 2, 2x, 2 times x, 2x, 2 times 2, which is 4. I'm going to combine my like terms. 2x and 2x can combine to be 4x. Everything else stays the same. So I'm kind of getting down here. Now I'm going to multiply this trinomial by this binomial. So I need to take x squared times 4x. That is 4x cubed. X squared times negative 3. Negative 3x squared. Okay, this guy's out now. Right, I'm done with him. Now I'm going to take 4x times 4x, positive 16x squared, 4x times negative 3, negative 12x. Now that guy's done. 4 times 4x, 16x. 4 times negative 3 is negative 12. Now that guy's done. Okay, so I did all my multiplication that I needed to. I'm going to combine like terms now. My like terms would be anything squared is the same. My two things that are just singular x's are the same. There's nothing similar to 4x cubed, so that one stays. Negative 3x squared plus 16x squared is 13x squared. Negative 12x plus 16x is 4x, positive 4x, and there's nothing like my constant out here. This now would be my original polynomial. Okay, so sometimes we start here and we factor and go backwards, right? We factor and find those zeros, like up here. Other times we start with the zeros and we work our way back down to find the polynomial. Okay, so that is going to be it then for 2.2. Thank you.